Hello, today I will be doing a bunch more Oxbridge interview style questions. Um, these are the kind of questions I'm going to do. They seem to be actually questions that have been asked previously, and even if they haven't, they're quite interesting. I've seen some of them. I know that I've made mistakes in my previous video, so because I haven't seen all of the questions, like I haven't done them properly. When I do finish sketching them, I will go in Desmos and check if I did it correctly. I will start with this one, which is an interesting graph because I think I've seen something very similar. Y is equal to x squared times 1 plus x over 1 minus x. Every time I see a polynomial of degree higher in my numerator than my denominator, I have been taught that I am meant to do polynomial long division. Before I do that, I need to note that at x equals to 1, my denominator is going to be 0. Therefore, this point is not defined, and hence I have an asymptote. If my pen, oh, my iPad is loading, but essentially I will have an asymptote. I'll write that down. Asymptote at x equals to 1. Now back to the long division. So this is quite a weird one because I'm dividing by 1 minus x, which is fine. It is just a bit uncomfortable. So I need minus x squared, not x cubed. Already going in the wrong path. So now I have x cubed minus x squared, 2x squared. I need minus 2x. 2x squared minus 2x. This becomes 2x. And here I need a 2. I have 2x minus 1. Therefore, my remainder is going to be 1. So what this means is that I can rewrite y as y is equal to the quadratic there, minus 2x minus 2, plus 1 over x minus 1. Okay, so I can start actually sketching now. And when I do it here, I think that's enough space. Actually, I'm going to move this around. I There should be enough space, I guess. I hope so. I don't know where this comes from. Let's get rid of that. Okay. And I don't like this line, so I'm gonna try and do a straight. Actually, Miro should have something to draw straight lines with, I hope. Yes, it does. Just can't find it. This is meant to be a straight line, yes. Okay, bad straight line. This is a more of a curved line. Okay, nice. I have my x and y. So I have been told I have a negative quadratic as an asymptote, and x equals to 1, which is, I'm going to say it's going to be roughly here, is going to be asymptote. Now, this quadratic has roots at, let me think, I don't think it has any roots. Might be wrong. Q plus minus 4 minus, yeah, it has no root, so it's completely below the y-axis. So it's going to be something of the sort. Well, it is definitely going to come down to the other asymptote. And actually, I just realized there's another question that is right below it, so I'm making a bit of space. Okay, so this intersection between the two asymptotes is going to be quite important, so I want to make sure I'm drawing it correctly. Need to elongate my graph here a bit. And I am struggling to draw lines. This is quite embarrassing. Okay, that should be fine. So, I know that I'm going to have roots based on this. I have a repeated root at 1, what is at the origin, sorry, and a root at -1, which I'm going to say it's here. So, what's this going to kind of look like? And as it approaches 1, is there a negative value or a positive value? That's something to check. So let me try y is equal to a half. This is going to be a quarter plus 3 over 2 over a half is 3 over 8 over 4 over 8, which is 3 over 4, which is a positive number. That means that my graph, as it approaches 1, what's happening? It tends to 0. Well, no, what I don't know that. That's the point. Um, so I'm thinking something like this. Yes, because it does go all the way up to 1. Sorry, not 1, to infinity. So I'm thinking my graph may look something like this. Maybe I can draw this nicely. The repeated root cuts the axis at 1. Okay, this is awful. Perhaps it's my placement of the 1 that's not really ideal. Okay, that's better. And here I'm going to have something of the sorts. It's too sharp. Yes, I like that. That's much better. This is going to be my graph for the first part of the question. I'm quite satisfied with this. Um, okay, so the next part is the same graph but y squared. The y squared tells me that there is symmetry in the x-axis because if I were to substitute minus y into this graph, nothing would change, which implies that there is a symmetry in my x-axis. So how would I reconcile this with the graph I just drew? I still have an asymptote here, I suppose. And I don't know, I'm thinking something like this. This is giving me problems. It's quite annoying. My graph is I still have the roots -1 and 0, which is very important. But I guess one other way to think about this is that I have plus minus root of this. And the root of this doesn't exist when it's negative, so it'll be undefined in this point and in this point, so I don't have to worry about it. Aha, so yes, it's because it's undefined past -1 and it's undefined past x equals to 1, my new graph will look something like this, and I'm gonna try to draw it as nicely as possible. Why on earth do those lines not appear anymore? Okay, that works. So I'm gonna try to do this one as well. Okay, so I have x, y. So I have a asymptote here. And I should perhaps moving this more to the side might be better. And have -1 here. So my graph, which currently looks like this, is going to look like something of the sort. Um, and this is because if you have a square root, all of the negative parts are not going to be defined anymore. And therefore, this ceases to exist. I hope you guys can see my cursor, otherwise it'd be quite embarrassing. I'm not pointing to anything. I'm going to highlight it here in yellow. So this part is not going to exist anymore, and this part is not going to exist anymore under the new graph. So I am going to go on Desmos right now and check that this actually works. I should have had open. I should have opened that before. Okay, so my first graph was y is equal to x squared x plus 1 over 1 minus x. So yes, this is quite accurate. Oh yes, I guess one other thing I should do is probably work out stationary points. I mean, it's not too bad. I think anyone can find stationary points of this. Just differentiate and solve when it's 0. And this point might be harder to get, but it's fine. And the stationary point here is the same as here, so it wouldn't matter. Let me see if y squared also work. Yes, pretty much. So asymptote at 1. So yeah, that's I'm satisfied with this. That's quite good. That's pretty much correct. Okay, I got scared for a bit because I thought um I sketched it wrong, but it's fine. Okay, now moving on to the next question, which is going to be this one. I'm going to move up. Okay, this is more interesting one. Partly because I've never seen something like it. Okay, so how do I think about this? I know sine, because there is nothing sine is being multiplied by, and the only thing that can determine the amplitude of my wave, I mean my sine, it's the constant that comes before it. In this case, it's 1. I know that the maximum minimum value of sine is -1 and 1. Now, what is there to check is that if it can reach -1 or 1, or if there is some point that it is undefined at. If I can use my iPad pen correctly, I can probably write this down. So, one thing to note is when is 1 minus x squared equal to 0? So I want to see all the roots of this equation, and I know sine 0 is 0. Okay, when is this the case? Well, clearly never, because 1 can't be 0. So it seems like I cannot reach that value. However, if I check my other root, which is pi, 1 minus x squared is equal to pi, I get 1 is equal to pi minus pi x squared. And here I get a very nice quadratic, because now I have x squared pi is equal to pi minus 1. X squared is equal to pi minus 1 over pi, and therefore my roots are plus minus pi minus 1 over pi. And if I go full on engineer mode, I am doing 3 minus 1, 2 over 3, 2 over 3, root 2 over 3 is, I mean, I think it's slightly less than 1. Okay, so this is not too bad, but I can generalize this. I know for every integer k pi is a root of sine. So if I generalize this argument to find all the, oops, and Myra is loading again. But if I do this for 1 over 1 minus x squared is equal to k pi, where k is an integer in the real numbers. There was no need for me to specify that, but still, k pi, if I do the same argument, k pi minus k pi x squared. And now, if I solve this quadratic, I get k pi minus 1 over k pi. Therefore, my roots are going to be plus minus k pi minus 1 over k pi, where k is an integer and k is not 0, which is very important. Now, that means I can generate all my roots for pi, for sine, for this specific sign at least. So when k is 1, I think we've already looked at pi minus 1 over pi, but also we have plus minus 2 pi minus 1 over 2 pi. Then you also have plus minus 3 pi minus 1 over 3 pi. So it's interesting. And there's a graph sketch I did yesterday actually that reminds me of this kind of process. And as my roots progress, they will get closer and closer together. So I feel like I can employ the same sort of argument here. That's kind of my base intuition. If I take, for instance, the general root, I'm going to consider positive case for now. So I have k pi minus 1 over k pi. I can rewrite this as 1 minus 1 over k pi. And I think this is a very important step because it allows me to realize that as k pi increases, what happens essentially is that 1 over k pi becomes a smaller number. That means I'm removing a smaller value from 1, and because the numbers from 0 to 1, when you square root them, you actually get a bigger number. What's essentially happening is that I am getting a larger square root. At least, for instance, if I have a being between 0 and 1, if I square root a, that's going to be larger than a. And the inverse is true as well. If I do a squared, this is less than a. For instance, consider half. Half squared is a quarter. So yes, I think my argument there works. So essentially, this is larger than 1 minus 1 over k pi. I believe that's correct. And as k pi increases, my square root, the difference between each root is going to decrease. Is that correct? I think I can check that actually. For instance, let's say I have 1 minus 1 over pi. Let's square root that. That's roughly the square root of 1 minus a third. I am going full on engineer mode, and there's probably a better way to do this, but it is what it is. And let me try 1 minus 2 pi, which is roughly 1 minus a sixth. This is 5 over 6. Are there nicer numbers I can use? Okay. What gets me? What minus a third? No, not minus a third. Can I do this? Well, because if I try 1 minus 1 over 3 pi, I have 1 minus 1 over 9, which is 8 over 9, which is 2 over 3. And 2 over 3 is larger than this. Okay, so progress. What does that mean actually? Yeah, I mean, I am quite stuck. It's just I know what I'm saying is correct. It's just doesn't make sense. Does it actually make sense? Okay, I think I'm thinking too much about the roots. I know the maximum minimum values of sine is when it's pi by 2 and 3 pi by 2. I don't think I really have to work this out, but just for the case of doing this, minus 2. Well, I can do the general argument. This would work, but for now, I'm just gonna focus on one of them. This is going to be ah nice. So actually, all my maximums are going to be when x is plus minus k pi minus 2 over k pi, and assume my minimums are going to be k pi. I mean, I have 3 pi, so 3k pi uh, minus 2 over 3k pi. Yeah, oh, ouch, that I accidentally put my eye. It's fine. Um, I think this works. Oh, although, yes, I can see the problem clearly. Where k, I mean, actually, I should do this manually. One is equal to pi 3 pi by 2 is a minus x squared. Yes, minus 3 pi by 2 x squared. 2 plus 3 pi x squared is equal to 3 pi. Where is it? 3 pi minus 2 over 3 pi. So that's one of my minimum points, and I guess you can generalize this for all k. Okay, so, and I think this might be wrong for my generalization, but it's fine. I've got what I need. But it's just I can't figure out if it's going to look like this. Well, I don't even know if it goes through 0 at that point. This, nope. This, or something like, and then it's going to widen out and so on. That's kind of what I'm trying to figure out right now. And I'm going to say it's going to be the latter, the former. And actually, if I draw draw it nicely, and I'm gonna put, oh, I need to see what happens at 0. At 0, I have sine 1, and which is roughly 0.84. Don't ask me how I know this, but I think it should be 0.84. This is going to be 0.84. And my first point is going to be 1 1 minus 1 of 1 over pi, the root of that, and minus 1 minus 1 over pi. And my second one is going to be, I guess, closer and closer and closer, and so on. So my graph is going to look something like this. And okay, my iPad is having issues and it's not loading here, but I promise you I'm actually drawing right now. Is it going to widen out, or is it going to get more dense? I mean, my distribution of roots. That's what's it's bugging me a bit right now. It is drawn poorly. This is again drawn poorly. Okay, that's much better, and so on. Um, I don't know if there is a nice way to check without a calculator if my roots are getting closer and closer and closer on together. The best way to see this is going to be graphing this, but I know actually I do have an argument. The graph of the square root looks something like this, and you can see if I pick, let's say, the origin and 1, there is this change in value. But if I take, let's say, k and then k plus 1, these two being my points, there is a smaller change in value, being this one as compared to this one. And if I take some other point and that plus 1, you can clearly see that the gap, the arrow, the spacing of the arrow becomes smaller and smaller and smaller as the graph continues to infinity. So that's going to be, oh, what did I just do? That's going to be my argument to justify why the roots are getting closer and closer. So that's my final graph. I guess now I have to check if I'm correct. And I'm going to do that very much hopeful that I am correct. One, was it minus? Not plus. X squared. And I am a bum. What did... Oh, minus. Okay. Minus. Okay. Okay, so I was right about this. I just didn't predict this part. Okay, interesting. That's actually quite interesting. Um, oh, okay. And also, how did I miss this? X equals to 1, I just get 0. That means it's not technically defined at 1. What even happens at 1? Where it's 0. I'll assume... Where's 1? Where is 1? Aha! It hides out. Like this. That's an interesting graph. Okay. So that's what happens. Okay. Well, we learn new things every day. And I guess at minus 1 it is defined. Because this graph is symmetric in the y-axis. Okay, so I need to redo my argument. Why is it that this doesn't go to infinity, like the idea of roots? It does have infinite roots. How am I meant to predict this? That the spacing of the roots is eventually going to widen out. Okay, so I'm going to relearn how to do this graph because it's quite interesting. But yeah, how long have I been recording? Almost half an hour. Okay, I can do one more graph, and I'm gonna do another video. So which one should I do? I think I'm gonna go this one because I think it's slightly more interesting. Okay, that was an interesting graph. I got it completely wrong. I mean, I did some of it. So I guess I have to learn how to do that kind of graph. Okay, sketch the solution to this differential equation. Dy dx is equal to x plus y squared. There seems to be a simple separation of variables differential equation. I have dy dx. Oh no, it might be an integrating factor question. Is equal to x. Now, my integrating factor is going to be. Let me make this full screen. I need to stare at this and make sure I am not doing something stupid. I have dy dx minus y squared and is equal to x. I'm quite sure this is an integrating factor question. And if it is, if I can do this by integrating factor, then my integrating factor, I'm going to denote it as this. It isn't, it is like a non-linear first order differential equation. And I don't think, is it solvable? Uh, because it's just the degree of this is a bit, is worrying me. I can guess a solution, I guess. Sketch the solution to dy dx is equal to x plus y squared. Uh, the problem with this is that um well, I guess in an actual interview I would get hints, but right now I'm pretty much lost. I'm by myself in the middle of the night. So I need to think. I don't think this is. I can do this by intuition factor because this is not. Oh, my iPad. Oh, again. Uh, I need to find like one particular solution. Not even like some. I need to like guess a function. I don't know. Let's say x squared. That's the first thing that came up to my mind. A problem repeatedly occurred on Miro.com. Okay, my Miro is bugging. And it always happens when I am recording, so this is very annoying. So, I might need to ask my friends for a hint. Okay, let me try. Y is equal to x squared. Y dash is equal to 2x, and y squared is x to the 4. So x to the 4. No. If you guys see me stop, it's because my Miro board keeps on bugging out. Now everything is zoomed in, so this is very annoying. But yeah, I'm gonna use my cursor. I will get what's this? 2x minus x to the 4 is equal to x, and this is clearly not true. Let me try. Well, I can't do x. I want to do get constant. Let me try fractional. Let me try square root of x. I want to have y dash. Okay, I might have to reload Miro on a different tab. Just bear with me for a second while I fix this. This is I finally and x. So my new function is going to be this is also not correct. This is quite tricky. I need to keep on get. I think the only thing I can do is I have to keep on guessing. Yeah, I might have to call it a day. I am completely clueless. Unless I ask Google for a hint. That might work. Let me let me do that. I might have to do that. Uh Help. Why can't I do this? Where's the question from? It wasn't this one. Is it this one? I will do some more of these. There it is. Eventually. Right now I'm stuck with this one. Okay. No, I don't. I need a hint. Hint. The wonderful solution. Yet. I need to spend more than that time. I know. Don't am. Consider using the method of isoclines or drawing a direct. What the? The method of isoclines is a graphical technique for sketching the general shape of solutions to a first order differential equation. What? The thing is, I have never seen something like this before. By the way, the reason I use this AI is that I like him much better than ChatGPT. It's usually much more helpful. So it is nonlinear, thank you. That was quite obvious. What the hell is a direction field using ISO? See, this is stuff I need to learn by myself, and perhaps this is where I say I need to stop and go and learn how to do this stuff. I wanna I wanna say I am proud of this, not so proud of this, and I have absolutely no clue what's going on here. So I guess today I found out. You know what? I'm gonna do another video of graphs I know how to sketch. So bye.